You're up.
Thank you guys for coming in today. Welcome to Greenleaf Hydroponics. I don't know if you've been here before or not, but we supply hydroponic, organic fertilizers. We also sell systems. We help custom make systems, little odds and ends that you might need. We have a little bit of everything. So glad you could be with us today. My name is Marvin. Patrick here is, we work together and he helped out with this presentation as well. So I'm glad we could help spread some good information. Talking today about mixing nutrients, fertilizer for your either liquid hydroponic fertilizer solution or for soil gardening. With soil, there's a lot of dry nutrients that people use, but also liquid nutrients is real popular and a little more precise to use. So we're talking about that as well today. So there's a lot of different things that you'll see on a nutrient bottle and you're not quite sure, or maybe not quite sure what it says or what you need it for. So I want to kind of help break that down a little bit today, talk a little bit about some of the ingredients that you'll see on the nutrient bottle that are listed that will help you decide proper decisions as far as how much fertilizer you're going to give your plants, what kind of nutrients they're getting in their solution, and maybe what you might be missing out on. And also give you an idea of why certain fertilizers are in 2-part mixes or 3-part mixes instead of just one by itself. There's a lot of solubility issues with the different chemicals that are in the fertilizer, and they can form insoluble salts basically if they're mixed together. So for example, we have some different nutrients here. I like to keep my nutrients at home sealed up properly just in case there's any spills. Also kind of just keeps them in the dark in a nice cool place. Keeps things from breaking down as fast, especially with organic liquid nutrients. They have a certain limited shelf life, so you want to make sure that you store them properly to give the most life out of them. So you'll see a lot of times on nutrient bottles that there will be a part A and a part B, and that's going back to the solubility issues. For instance, this is just the Sensi Grow part B, and you look at the numbers on the front. It says 225. What that means is there's 2% nitrogen, 2% phosphorus, and 5% potassium in this concentrate. Now you're supposed to follow directions to make it into a solution that would be good to water your plants. Either that or filling up the reservoir. Either way, it's just, you will use those interchangeably. The thing about the B part is with the grow, you want to focus mostly on nitrogen uptake. That's when plants are using a lot of nitrogen. Also a little bit of phosphorus early on for the root development. So if you look at this by itself, you go, oh, well, it says grow, that's all I need, right? Not so much. You want to make sure by looking at this, you go, well, I probably need more nitrogen than this. So there's definitely got to be something else I need to complement this with. So by itself, you might be okay if you were in the ground and you weren't caring too much about your results, but you really need to step it up and get the 2 parts of the series. Okay, so that's where like something like this would come in. I find a lot of people come in and go, oh, I just need the bloom. Not so much. You see here, it's got the phosphorus, it's got the potassium, but it doesn't have any nitrogen in it at all. Plus the active ingredients, there isn't the micronutrients that you would need. So that's something people always, or oftentimes neglect or forget about, is that you got the nitrogen, the phosphorus, and the potassium, but you also want to make sure that you're supplying micronutrients to the plants. So in a 2-part formula, that's where something like this would come in. You got the micro, see there's no phosphorus in it, whereas this has lots of phosphorus. Another thing about that is calcium and phosphorus, you can't put those two in a solution together, in a concentrated solution. They'll form insoluble salts together. So calcium and phosphorus, also calcium and sulfur. Calcium sulfate is a common material known as gypsum. That is actually used in agriculture, but if you have that in a liquid solution, it will form together and it will salt out essentially. So it will form a sludge on the bottom of your reservoir. It will help clog your emitters, or not help, but unhelp, I should say. So it's not something that's just those are kind of things to keep in mind as far as you're mixing your solutions together. Another thing that I wanted to mention is there's something called chelating agents. Now what those are is you'll see in the back, you'll see your nutrients listed, and it will say something called EDTA. And what that means is it's an enzyme that will help bond different nutrients in the soil, mostly micronutrients. Iron's one of them. And what they'll do is, because of that chelating agent, it will help the plant be able to absorb the nutrient at any pH level, or a more broad pH level than we're used to with soil and hydroponic gardening. So you don't have to have everything dialed in as much. It's a little bit more forgiving in the solution that you make. So that is, it's almost necessary sometimes for certain micronutrients, because there's different solubilities, and you've got to make sure that everything's being provided to your plants, especially in hydroponics, because you're the sole provider of their nutrition. So you want to make sure it gets to it properly. So that's it about the chelating agents. You see, I have like the bucket, or I have this.
Hey Marvin, I've already got a question.
Yeah.
I'm sorry that you're blowing through like I know all this stuff, and since I'm the neophyte, I really don't know much.
Okay.
On the chelating agents, so it's helpful to bond up, so that because what it does is, doesn't it like bond with like the micronutrients and allows the plant to take them in?
Yeah,
So
yeah.
would you use that in both grow and bloom, or would you use it mainly in?
You would use it's literally built into the fertilizer solution itself. It's not, you're not adding the chelating agent per se. It's part of their recipe.
Okay.
A lot of times, if you see a one-part solution, which isn't recommended as much, but they use the chelating agents oftentimes with that to keep everything in solution.
Okay.
They are a lot more expensive, chelating agents are. So if you see that on your bottle and you're wondering why things are a little bit more expensive, that's one of the reasons why, okay? They are, at least 4 or 5 times more than the actual fertilizer itself. So that's one thing to keep in mind when you're looking at the price tag of things. So as far as mixing your solution, there's different rates that nutrients can be uptaken by plants, and a lot of that has to do with where it falls within the pH range. Okay? There's the soil gardening, there's hydroponic gardening, there's different ranges that you want to stick within to make sure that everything's available, you're getting the most bang for your buck, you're making the most efficient use of your fertilizer, and your plants stay happy that way. In hydroponics, I shoot to keep the pH around 5.8 to 6.2, 6.3. Those are good ranges. I shoot for towards the lower end of that scale when plants are young, and towards the higher end of that scale when plants are getting older into their bloom phase and then finishing up. As far as the soil goes, there's a lot of different opinions about that, but I shoot for around 6.3 pH in my nutrient solution, upwards about 6.7. Now tomatoes, they're actually known for enjoying a little bit more of a basic grow media, and so you can shoot for anywhere between 6 and about 7.5, and you'll have no problems with your nutrient uptake. They're a big fan of potassium, and potassium is one of those nutrients that are actually more available towards the high 6s and the low 7s. So is everyone familiar with pH adjustment? Okay, we'll just talk about that just a little bit. The water that we have here in Southern California and a lot of the Southwest is provided by the Colorado River and local aquifers. Most of the water that we're getting from the Colorado River is full of it's full of calcium, it's full of sodium, a lot of magnesium too, all in kind of funky ratios that aren't necessarily good for plant growth, okay? There is certain ratios that we like to shoot for in hydroponic and soil gardening as far as nutrients being provided to the plant in the amounts that they need. Calcium is one of those, magnesium is one of those, sodium is one of those that you definitely want to keep out of your plants as much as possible. There's a little bit needed in its biological processes, but nothing in comparison to the calcium and the magnesium that is coming in our water. See, the problem with that though is the ratios are all screwy, and it's causing nutrient lockout problems. Also, right off the bat, your water has a high ppm, and if you're adding more nutrients to that, at a certain point it's going to be more concentrated or salty than your plants are going to be able to handle. If there's too much concentration of salts outside of the plant and not enough water especially, it'll suck the water out of the plant literally, and that will help it. It'll die essentially. So something that you want to pay attention to. That's one of the reasons why I'm a big fan of the reverse osmosis water, or filtering your water any way you can. Water that comes from the city. You can find your water report for your city on their website. This one for Anaheim that I was looking at. Our water here, 8.2 pH, really high in the calcium, like I was talking about. Also a lot of little heavy metals and stuff that you'll find. Things from like industrial processes, or chemicals that have been spilled into the ground and have made it into the groundwater. All those are the kind of things that most of us would rather not put into our bodies. So that's one of the big reasons why evaporating the chlorine out of your water is helpful. Using reverse osmosis water is really helpful. That will eliminate the salts from your water and give you a fresh base to start with, so you know exactly what you're inputting into your nutrient solution. Okay. Now that means that you have to make up for that calcium and that magnesium that you had in the water before. A lot of outdoor soil growers, they just factor in that calcium that they're getting and then fertilize a little bit less with their calcium supplements. But with the hydroponics, especially since you have to provide everything the plant needs, you have to make up for that. So that's where solutions like CalMag come in. Okay, that's what those are for.
I have a question.
Yeah.
How do you evaporate chlorine off your water?
Most people just let their water sit out overnight. I had a lady in here the other day saying that she read that you could use a air stone with an air pump and help evaporate it out more quickly that way. And she said that roughly 3 or 4 hours was doing the trick for her.
Wow.
I don't know if that was, that's not a scientific fact or anything, but that's definitely something to look into.
And how was she getting her results by like the ppm measurement before and then afterwards, or how was she knowing that it was successful?
It was something in the reading and like a sort of like a word of mouth kind of deal. So that it's, like I said, it's not a fact. It's just something that I've heard recently that I think has merit. The chlorine is one thing that is not so beneficial for your plants. So you definitely want, different plants have different chlorine sensitivity issues. A lot of houseplants are like that. A lot of vegetables are like that as well. So that is definitely something to take into consideration. We have units that we sell that will, are dechlorinating units that you can make, 100 gallons of water for yourself a day. And then the next step up is we have reverse osmosis systems that you can hook up to your water just like this and make your own water for your system. Okay.
Quick question as well that I haven't heard about, but does anybody use any of the chlorine things like used in fish products? Because they make the water conditioners that.
Oh, like a dechlorinator?
Yeah, they kick out the chlorine and chloramine. I just did when you were talking about the aeration, because I know for them it's a longer process. The air helps.
I read I remember reading a bottle of that stuff because my parents have a koi pond at their house, and I remember seeing something about that there was something in that chlorinate product that wasn't totally healthy for the plants. But I mean, I have used the water from the fish tank. Eventually that chlorination kind of it does come off. So this is another thing that you can use. This is a dechlorinating filter, and you basically just hook this right up to your hose. So that's a good way to do it. This is basically like a carbon filter inside, so just like you would use in your drinking water at home. So for pH adjustment, there's a lot of different things you can use. Another thing is that fertilizers actually have an effect on your nutrient solution. So a lot of people will add their water and then pH it and then add their nutrients. And what you got to realize is the nutrients that you're adding affect the pH of your water. So you want to test that after you've added your nutrients and then make your adjustments afterwards. What we use is for pH down, is what you're most likely going to need to get to those low 6 ranges for soil and the high 5s for the hydroponics, is pH down. This General Hydroponics makes a really good brand that's the most popular. Advanced Nutrients also makes one that's a little bit more concentrated. You can also find organic versions that are granulated or powders. Some people use vinegar. That vinegar is not buffered as well. It will not last as long in a solution or stay as long in a solution. If you pour vinegar into your hydroponic reservoir and expect it to maintain that pH all week long, it's just not going to happen. Okay, I do recommend that using that sometimes for foliar feeding or pesticide applications, because you're expecting to use that stuff right after you make it. So one of the things that I wanted to point out about pH down is this is essentially just phosphoric acid. So phosphoric acid, phosphorus, if you will, I mean, that's a big component of most bloom fertilizers, a lot of root starting fertilizers. So just know that when you're adding this to your solution, that it's bumping up your PMs a little bit, and that you're getting a phosphorus source. So that's just one extra way of, like, technically using a bloom booster, if you will, on your plants, and you already have the pH adjust anyway, so it's something to keep in mind. The pH up, this is made from potassium, okay? So that's one thing to keep in mind as well, is that potassium tends to raise the pH of your nutrient solution. Or if you add potassium to your soil through a dry method, either way, expect a little bit of a pH increase. So that's one thing to keep in mind. Now, some of the things that we use for this pH adjustment is, I'm a big fan of these dropper pipettes. You really don't need a lot of pH up or pH down when you're adding it to your solution. And using something like this helps keep things safe. You know, you don't want to get this stuff in your hands. I got some pH up on my finger the other day, and it totally bubbled up and formed like a callus. So it's not something you want to mess around with. Ideally, you want to be wearing gloves. Most people don't, but ideally in like a lab setting, you'd be wearing gloves, nitrile gloves, you know, something like a rubber kind of texture to keep any of those chemicals off you. Also, the nutrients themselves, once they've mixed in a solution, not too harsh, but if you pour, you know, if you get some of these chemical fertilizers on your hands, or anywhere on your body for that matter, or breathe it in or get in your eyes, you know, that's you're looking at a trip to the hospital, and if you get enough on you. So be careful with that. Ideally, like if you were mixing solutions up outside, maybe far away from your house, in like a guerrilla type setting, you'd want to keep a bottle of water close by, just in case you got this stuff in your eyes. You could flush your eyes out really well, or, you know, wash your hands off really well if you needed to. Also, be sure to always wash your hands when you're done doing this kind of stuff, especially before you go to the bathroom. I mean, just do the math. So, talked about water, talked about nutrient lockout. One of the things that will help keeping your nutrients in the solution and stable is having the solution be constantly aerated and mixed. I mix these up really well into the solution, but you will expect them to settle out a little bit if you leave them sitting still over the week, especially with your organics. If you want to maintain an aerobic environment, if you have an anaerobic environment, different kind of bacteria start getting in there. You start having problems with ammonia and smell, and then the next thing you know, you have diseases and bug bugs. So it's you know, it's one of those steps that just keep things all and working order. So we got the pipettes. There's all different kinds of measuring cups and spoons. The syringes are also really nice. They're just kind of the same concept as pipettes. You can get a nice, precise, accurate measurement with these, and not have to worry about getting the stuff on your hands as much or spilling out of the bottle. There's all different kinds of units that they use, you know, European stuff, milliliters, liters. Then there's, you know, teaspoons, cups, ounces, and you'll find all these different kinds of measurements listed on the back of the nutrient bottles. So one of the things that I do is I like to have multiple readings. That way I can kind of just go back and forth whenever I need to. That way I can mix and match nutrients and know exactly what I'm putting in there and not having to be guessing or you know, stumbling on my math or anything. Now, since I'm not a math whiz, I have a conversion table that I make up for myself, and I have extra ones of these if you want. But it basically does things like calculates, you know, tablespoons to cups and teaspoons to milliliters and ounces to, you know, gallons, and all the different things that you're going to need more and more, especially as you move up your the amount of gallons of solution that you're using. You know, you want to make this stuff accurate, and you know, these nutrients aren't cheap, so you want to use them efficiently, and you want to make sure you're giving your plants what they need and in the right proportions and in the right amounts. Okay. So that's definitely helpful. We also have, if you want to get a little bit more into it, now I definitely recommend this for hydroponic gardening since you want to have things more precise. One of the reasons why the whole precision I keep going back to
A little
is
more effective
with the hydroponics, especially with the reverse osmosis water, it takes more to adjust the pH. There's not as much buffering capacity in that water. The calcium and the sodium is something that resists change the pH, buffering in a way. So it takes more pH adjustment to adjust a solution that has a calcium and sodium starting out in its base. So with that in mind, and with those more precise amounts that we're needing, I look for something more like a pH meter. This is digital, also a TDS meter. The pH, that tests your pH, gets you an idea of where you're at as far as your nutrient availability. And then the TDS meter, that's for measuring the total dissolved salts in your solution. Okay, there's certain ranges for different different stages of the plant's life, different kinds of plants. For example, we set up the reservoir over there for our tomatoes, and we set the ppms at roughly 1,000. Okay, that was a good start for a plant that's pretty young, vegging out, didn't want to push the limits too far, and that's another point is that it's better to go a little bit less than more when you're starting, especially when you're starting your first nutrient application. Is you can always add more later to kind of make that go, but you can't take it back if you add too much nutrient solution and it's too concentrated. You risk burning your plants, you risk burning your roots, you risk having a pH that's all out of whack because you've thrown in extra nutrients that it doesn't need. So it's better to start with like a small sample. If you have the time, you can try it out on like a couple sample plants and then go from there. But flushing isn't going to bring back that amount of burn and shock that your plants will go through if you give them like a double strength nutrient solution or even a full strength one if it doesn't need it. A lot of the soils that we have are chock full of nutrients, like a fox farm soil. So if you start throwing full strength nutrients on it right away, you're going to see burn issues. There's too much salts in your plant. So those are helpful. It's also nice to have these cups because when you're measuring the solution, I find it's easier to just dip this into my reservoir or into my bucket that I've mixed up my nutrients in, and that way I can just take a stable reading from a small sample and not, reaching over into the reservoir. With the aeration, it tends to, for me anyways, it seems to throw the readings off sometimes because it's constantly being bubbled on and things are moving around so fast. You want to let that stuff get all mixed in. I use something like bamboo sticks to mix up my nutrient solution, especially if it's in like a bigger size tank. Or if I'm doing something by hand, I'll use like a small bucket or a watering can. You want to make sure that stuff gets mixed up really well. The wood and bamboo stakes are really useful for a lot of different things, and that's just one of them. So another thing that I wanted to mention is that when you're adding these nutrients to your water, you got to add the nutrients to the water and not the water to the nutrients. If you mix the nutrients together before you add them to the water, you're going to get lockout problems. That stuff's meant to be in a solution, and then it can mix within the reservoir, and the salts won't fall out. So you got to keep everything available. One of my friends uses like ketchup bottles. He puts his pH up and down in that, and that's a really easy way to apply those chemicals quickly and easily. It's not as precise because you just a couple squeezes here and there, but if you can get it down, in the system that you're working on, and you have a sort of rule of thumb for yourself, it's a good way to measure things out, I feel. So the nitrogen. Talk about nitrogen, lowering the pH of fertilizers, or lowering the pH of your solution. Also lowers the pH of your soil. When the nitrogen is breaking down in the soil, it donates a hydrogen ion, and the whole chemical processes of all that, the soil's acidity is lowered. So So that factors into, like, some people have a pH down that's made with nitrogen. Some people use things like fish meal or fish emulsion or fish-based products in their liquid feeds. Those tend to be acidic as well. So in the past, I've used that, and with that in mind, I've used that as a pH down in addition to a nitrogen feed. So you can kind of cover two bases at once. So another thing about nutrient ratios, like when you look at the water, we have about twice as much calcium as we do magnesium in our local water here. Ideally, in an agricultural situation, you're shooting for a ratio of about 5 calcium to 1 magnesium. So that kind of plays into the whole using the RO water and keeping that in mind to where, okay, I'm going to add my Cal Mag now. I'm going to, pay attention to these ratios that I'm adding on to dial everything to the ideal settings that you're looking for your particular crops. There's more than just calcium, magnesium. There's certain things where if there's an excess, like potassium, that will start hindering the uptake of other things like calcium. There's a whole laundry list of different nutrients or like that, and so that's one of the big reasons why you want to make sure you apply everything accurately, and you don't just apply the part B, but you apply the part B and the part A, because now it's not just that you're not giving one enough, but now one might not even be available in the soil because, or in your reservoir, because everything's all wonky as far as your proportions are going. So that's something to pay attention to. Ideally, most people clean out their reservoir once a week. There's different styles. Some people just top it off with water and let it go. There's different kinds of recirculating systems, all different kinds of systems. But ideally, I say shoot for cleaning out your reservoir once a week. Change out the nutrient solution entirely. That also gives you time to check your parts, make sure everything's working properly. We found a small leak in our flood table the other day when we were changing out our reservoir. So I mean, stuff happens, and that gives you the time to make the correct fixes. Silicone sealant was our fix in that case. But that also gives you time to check out your drippers, make sure things aren't clogged. Maybe give you time to spray. So there's different things you can take care of. Another thing is you want to make sure that you have a nice, sterile, clean environment. So when you are emptying out your reservoir, I recommend using things like bleach. We have something called Floor Shield that's good for cleaning, as well as H2O2, which is a really concentrated hydrogen peroxide based cleaner. That's often used for to combat root rot, but as well as cleaning out the gunk in your reservoir. That's what we use, and you can see it happening. I mean, it's sizzling in that water, and all the algae growth and all the gunk was just sizzling and fizzling away. So definitely big fan of that. There's a lot of different ways to empty your reservoir. It's the simple, just take a bucket and empty it by hand is, common. Another thing you can do, which I like to do, is I get a sump pump, I hook it up to a hose, I throw that thing in there, and I pump that water out, preferably into a spot that needs it. Okay, the water that you're pumping out of your reservoir, even though you've used a lot of the nutrients that are out of it, there's still nutrients in it, there's still salts. That's something you wouldn't want to just dump into your local creek or river or anything like that. Large-scale nurseries have runoff problems in a more of a home setting, not so much of an issue, but use that leftover nutrient solution to your advantage. I have a friend that pumps it directly into his garden plants, so his palms and his bromeliads and his azaleas are just loving it, and like you can tell, I mean, it's the kind of lush green that you don't get from Home Depot fertilizer. It's really those plants are loving life right now, so good for them. Another way you can do it is some people have a little bit larger reservoirs, a little bit more water that they know what to do with. Some people do just run it into a drain. It's doable. That's something you kind of want to get a plumber set up for. But we do have water purification facilities and stuff that the nutrient solution you're putting down there is better to put it in the drain than to just dump it right onto the ground and have it run into our ocean or and our local groundwater. So another thing that you can do to help pump that water out instead of using a bucket or the sump pump is there's a pump already in your hydroponic system that's running a tube up into your flood tray. You can put a T into that, put another shut-off valve, the one leading to your reservoir, your flood tray, and that way you can just T in, open a valve, and run a separate tube off of your reservoir, and that way you can run it as long as you need to hook it up to another hose somewhere else, or run it into larger barrels that you can wheel out or drain out somehow. So that's a way of doing it where you don't have to get your hands and your head all into your reservoir every time you want to drain it out. You can just kind of do it from the outside. So that's a quick and easy way to, it's a more convenient way once you have set it up, so I do recommend doing that. So there is feeding schedules. Now that's really eliminates a lot of guesswork out of feeding your plants with nutrient solution. They have them for soil, they have them for hydroponics. We have quite a bit of them listed in our catalog, kind of in the middle around page 113 or so. But you'll find all of these online. This one, right, Botanicare, Advanced Nutrients, Fox Farm, General Hydroponics. I mean, every company has one because they want their clients to have the best results possible. It eliminates a lot of guesswork. I've been around for quite a long time, but I still find that if you try to get creative and make your own little mixes, there's you're adding extra variables that you don't really they're not necessary all the time. And so the guys that they have working for these companies that are putting these feeding schedules together know what they're doing. Advanced Nutrients has 12 PhDs working for them, and they're constantly improving their mixes and constantly updating their feeding schedules, testing on plants, doing tissue cultures, doing tissue samples and soil samples and water samples. And so it really does pay to just to find a nutrient line that you like and kind of stick with it. A lot of them are interchangeable as far as they have similar ingredients and similar points of use, but as far as eliminating the guesswork, cutting out the extra variables you don't need, the nutrients that the companies make are meant to work with the nutrients that they make. That's what when they're testing these plants, they're testing it with their line of nutrients. And they'll do side-by-sides with other companies, but they don't do half their product and half someone else's product, which I've tried in the past and I've had good results with. But as far as locking everything into your ideal settings, they've kind of done all the work for you as far as figuring that out. So I do recommend going with following a feeding schedule. I do recommend starting out at half strength the first couple weeks to eliminate any risk of burning or anything. But once you've decided that your plants are ready for it, it's best to go full strength all the way, just to maximize the quality and the yield and everything else that you're going for. So got that. So I've made a list of a lot of different things that are useful for pH adjustment, for making up nutrient solutions. I printed out a bunch of stuff that's over on that green table right there. We also have some highlighted points that we talked about. There's one for him too. Okay. A couple other little things that I wanted to mention is going back to safe storage. You want to wear the gloves. I've also had problems with animals in the past getting into my nutrient solution. So that's something that you want to pay attention to. That's one of the reasons I'm a fan of using things like buckets to keep things sealed up. Tried using organic-based liquid nutrient solutions indoors, things from the Fox Farms line, for example, that my friend's dog, young puppy, ate right through the bottle. There wasn't anything dripping off to the side or anything like that. The lid was on nice and tight, and he literally chewed through the bottle and wasted a big old gallon of nutrients that I had to pay for again. So not only that, but you have an animal that's possibly getting sick from eating this stuff. So that's one thing that you want to pay close attention to. You really don't want animals close to your grow rooms anyways. outside in the yard, not so much of a problem. But this on like a larger scale, I mean, these guys, these fertigation guys in like the Central Valley, they have their nutrients within like a concrete like holding center. So if things were to spill out, it would spill out onto concrete and then drain away into a safe spot. So that's like on the large scale of things, just giving you an idea of, you know, or here's another one, like their nutrient tank is inside a bigger tank. So if anything were ever to spill out, it's not going to get on the person, it's not going to get into the groundwater, it's not going to get on your carpet, you know. So you can dial that down to a smaller scale using things like buckets and trays to really help keep things neat and tidy. Another thing that I want to mention is it's best to not be doing things like drinking or eating or smoking while you're doing all this stuff. Not really worried about anything flammable as far as these nutrients are going, but you don't want to be breathing in extra fumes that you don't have to. You don't want to be accidentally like, oh, this is water, or this is, you know, I'm not sure anymore. And, you know, you don't want to ever store your nutrients, or especially things like your pH up and pH down, in things that aren't labeled, okay? The ketchup bottle, those work really well, but that is something you have to pay attention to as far as like, you know, just use common sense. Like, you don't want little kids getting into your nutrients and they see it, oh, this is in like a soda bottle and I'm gonna drink it now because it looks like it's soda. You know, just use common sense, be cautious about things, be aware that things like little kids and dogs, they don't always know better about, you know, about being safe and keeping out of things that could harm them. So that's something that's really important. That's kind of what I wanted to touch on last, because it's one of those kind of hidden things that we don't really come up too much. But so does anyone have any questions?
Thank you.
Cool.
So are you measuring your pH before you add your nutrient and after? Or
I do
just
sometimes, just to get an idea of where my water's at. I like to have that as sort of a reference in case I'm ever stuck without my measuring devices, you know. And I like to get an idea of how much, like if I'm ever going to water with just plain water, I still like to pH adjust my solution. So I like to, you know, I don't adjust it if I'm going to add nutrients to it. I'll adjust it after I add the nutrients to it, okay? But if I'm just having plain water, I'll adjust that by itself.
And what about ppms? Are those before and after? Like
well, that's something to take into consideration. It's good to check it before if you're going with tap water or well water or water that you're not sure of, because you're getting like a standard reference of where your starting point is. The water around here, 400, 500 ppms right out of the tap, a lot of times, sometimes even more. So you have to factor that into what your maximum total dissolved salts is that you're going to be giving your plants. Okay, you can't just disregard that part of it. So it's good to know, you know, and I do that through testing, and I also do that through getting to see water quality reports. They'll send them out in the mail, usually yearly, depending on whatever city you live in. But I found that it's the quality reports are really similar. Anaheim, Costa Mesa, Huntington Beach were all like basically the same as far as their what you'll find in the water. But yeah, so it's good to test it before and it's good to test it after. One of the things that we do have for people like yourself that want to get more technical is these Guardians. These are basically constantly reading pH and EC testers, and they test TDS. EC and TDS are often used kind of interchangeably. You can use one or the other. In the US, TDS is basically the standard. There's a mathematical conversion for them too that I don't have on the top of my head. But so something like this, these electrodes would be sitting in your reservoir constantly, and it would tell you up here what the temperature is of everything, the pH is of everything, the conductivity. So that way, it's for a larger scale operation, or just for someone that likes to have everything down exactly the way they want. You know, they can look from a distance. I'm the kind of person, I'll check my solution every day because I'm always thinking about, you know, I'm already there checking everything out anyway. So I'm checking out my solution, making sure everything's on point. You know, if you have something outside, you're going to have more evaporation issues. Even inside, things start evaporating, your nutrient solution becomes more concentrated because there's less water, but still the same amount of nutrients. So those are all things that that I like to keep track of. Okay. One thing I didn't talk about was that some people, as the reservoir is lowering throughout the week, they add water to fill up, to top back up their reservoir. Some people do this, some people don't. It kind of depends on the type of system you're using. Some people talk about adding not just water, but about a quarter strength nutrient solution to refill your reservoir. To refill it with 100% nutrient solution before you've actually cleaned it out. Like, so this is, let's say day 3 or day 4. If things become too concentrated, probably gonna run into problems with that. So that's not something I recommend. It can be done, but not something I recommend. Oh yeah, another thing is you always want to make sure that these things, your equipment is working properly. We have calibration solutions. We have this kind. We have ones that are in a smaller packet, like for more of like a one-time use type of deal. But basically what this will do is you'll take your pH pen. These solutions are set at a certain level. This is 7, always. This is 4.01, always. So you'll use, and they have the same thing, similar concept for the TDS pens. Now you can also get pH and TDS pens put together. Like I have one of those. It's a portable hanometer, a little bit pricier, but that way I just have 1 meter and it's always ready to go. I like it. So what you do with these is when you calibrate these things, you want to make sure that they're working properly. So you would pour a small sample of this, set up your calibration. The more accurate meters calibrate to 2 points. So you would calibrate it at 4, and you would calibrate it at 7, as per the instructions of whatever type of meter you have. And that way, you're getting accurate measurements when you're reading the nutrients in your reservoir. So a similar kind of concept for the TDS meter. You're gonna need to calibrate it. Some people say calibrate it every time you use your meter. I think that's a little excessive, but if you're the kind of person like me sometimes that has to maintain constant monitoring and really are into exactly how everything's going at all times, then yeah, you want to test it, you want to calibrate it at least every so often, once a week at least. A problem that I wanted to talk about that happened to me the other day, just like one of those learn from experience type of deals, is made up 50 gallons of nutrient solution over there for our reservoir, and I tested the TDS, and TDS was just fine, just exactly where I wanted. And I tested the pH with our meter, and the pH was like 8.5. I was like, oh, that's way too high. I want to get it down to like the low 6s because we're doing soil. And so I added a capful of pH down, which is really all you need in a lot of cases. This stuff's really strong. And I waited a little while and I checked, and it had gone down to 6 or so, and so I was satisfied. And then the next day, I checked the pH again, and the pH was at like 3.5, and I was saying, what's going on here? I just tested this yesterday, it was fine, we haven't added anything to it. It's in a 50-gallon reservoir, so that's a lot of nutrient that's really well buffered against changes. Like, it's not like I spilt an extra drop in there and it threw everything out of whack. So it's like, what's going on here? This meter's brand new. I think it's brand new. I think it works. We've maintained everything, and can't figure it out. So I add some pH up because it's at 3.6, and I check again, and the pH hasn't gone anywhere. I'm like, okay, something's wrong here. I've added this pH up. This stuff's really concentrated, just like the pH down. My pH should have gone up in my reservoir. I'm gonna go take this pH pen and clean it off and see what's wrong with it. And sure enough, I look at the pH pen, and you're supposed to store these things in like a storage solution inside this little cap that slips over your diode. There's a storage solution, or at the very least water that you put in there. But you want to take care of these things. These are specialty tools. You want to make sure they're good, because what had happened in our instance is there's a little glass diode in here that's responsible for measuring that those reactions in the water to measure pH, and it had broken, and it had been broken for who knows how long. But so it's like I was doing everything right, but if your equipment's busted, it's not going to do you any good. So it's good to do things like calibration. I figured out it was broken finally when I was washing it off in our bathroom sink, and that goes back to our water reports. I know our local water is like in the 8s somewhere, and so when I'm washing this off in the sink and it's reading 3.6 still, it's like, okay, now I know that there's something, this thing's broken, you know? So it's good to have as many different ways of calibrating or ways of reference as possible. You know, even though I'm all about the meters now, I still have this at home because if my meter's like, I'm not sure if my meter's still working as good as it should. I've had my meter for 10 years, it still works. But for that extra level of, you know, accuracy, I will use this in addition to my meter just to be like, okay, everything's still working properly. Everything's still, you know, as a way of calibrating.
I have a question with
Yeah.
that. Would you still be able to use that pH tester even after you've added the nutrient?
You can. The only problem with it is a lot of nutrients is the color.
Yeah.
Exactly. Like they'll have dyes in the chemical fertilizers, or the organic stuff is yeah, all the brown and black colors that are in there. It really throws off your measurements. I find, you know, if you mix it up really good, it's still kind of like that. So that's why I think it's preferable to get a meter, because it doesn't worry about the color so much. Yeah, and this is more of like a backup. Another thing that you can run into is some of the nutrient solutions have their own kind of gunk in them, you know, solids, and that's why you want to make sure you shake up your nutrients really well to make sure everything's in solution, everything's consistent. And another what you can do is, if you find that there's a lot of chunks in it, you can strain it out through like a strainer. If you're using thicker nutrients like that in something like a drip system, something like a soaker hose, or things that have really small emitters, the aeroponics mist, those are the kind of things that will either clog your system or you know, cause problems with your pump. So I usually recommend that people don't go the route of like the thick organic liquids for that type of a grow system. But you know, there's different ways for each style that are beneficial. Anything else?
Do you guys still do calibration and pH testing for free here?
I will pretty much just.
You guys used to do?
Basically just charge for the packet.
Okay. So you guys used to do support for those meters and stuff? I couldn't remember.
Yeah, we can do that. I mean, most. I mean, they have instructions with them that are pretty easy to follow. But I'd have no problem helping out anyone that, you know, has any questions about these kind of things as far as keeping them calibrated, keeping them stored properly. Because they are a nice tool to have, and they'll last you a long time if you take care of them right. But yeah, if they're not calibrated properly, if they've got a broken diode in there, you're doing yourself more harm than good. So best to make sure that they're maintained and well cared for.
The other little thing is, if somebody happens to have a blue lab one, I don't think they ever changed that, did they? How they go together? We had a lot of trouble with the blue lab ones a long time ago because the cap can be switched both directions. And so if you go one direction, there's this nice space for the diode. If you go the other direction, it's crunch. And we let the company know, and nobody said anything. But so a lot of people were taking a black marker and putting like a black strip on one side of where the white and the blue joined. Because it's a great instrument, you just got to make sure you put the cap on safely.
Yeah.
So we put together a couple little starter packs, if you will. This one over here, it's kind of like get you started off with pH adjustment, nutrient application, you know, pH down applications. We threw this together with the measuring cup. Runs you $30 out the door. Or we have this one. Next step up would be a TH meter and a pH meter. We got our own, these shot glasses really, or it says exact shot, but these measuring glasses are really nice as far as having the different conversions on them for you already. So this is what I use over there for our 50 gallon, because I can measure up a whole cup at once, and I can, you know, see because it was in milliliters, and I converted to cups, and I could do all that just by looking at this glass here. So that's really helpful. Another measuring cup, get the nutrients out of your bottles. Also helps for mixing up or for measuring, a small sample of water. You can just do it right in there. So we did this all together. These bad boys out the door is $100, and definitely a worthy investment. I mean, as far as getting things precise, getting things, making the most out of your nutrient solution, that's a big factor. Very helpful. So, like I said, my meter just lasted me over 10 years, and I use it every week. So, definitely good to have. I mean, you can run out of these pH drops, or over time, this label will get faded away, like in the sun, and from if you ever accidentally splash like any kind of stuff on it, it'll erode away. So these are works. This is better. This kind of depends on what. And then obviously this is top of the line. And if you want to go even further, they have ones that we can special order that are the constant monitoring type of systems that will also add nutrients and pH adjust your reservoir for you. That's like on a commercial scale. You're looking into hundreds of, or if not thousands of dollars. But for certain people, I like the way they're thinking big, and that's one less thing that you have to do, and you can focus on something else. So the sky's the limit, really. I mean, they have stuff that you can monitor. Once with that, and then you can monitor it from your computer at home, or your iPhone even.
What do those run?
These meters?
Yeah, for the full setup.
This is roughly like $350, and then you can get different ones. The combo meter that I have, the ECTDS pH temperature meter from Hannah, those retail roughly $180. Most pH, like this is a pretty high end constant reader. They have other ones that retail around 200, $250, different brands. There's different companies that are more reasonable than others. I'm a fan of the Blue Lab and Hannah Instruments. That's the meter that I have, and it's never done me wrong.
Well, to comment on the Guardian, we have customers that have them on every reservoir in the facility. It makes it handy because then somebody can walk through the clipboard every day and, okay, tray number 2 is this, and tray number 3 is this.
Yes.
So if you really want to take it to a level where you're dialing in your newts, that's the bomb. And we've had really good support from that company as far as them maintaining everything. And no issue.
Right on. Anything else, anybody? Yeah, there's a lot to cover.
Thanks.
I've kind of been told that if after you add your nutrients to your water, you should mix it and then aerate it for like 30 minutes before you can check the pH, because it'll kind of rise as you go. Is that kind of true?
It is true. You want to. I mean, a lot of times I have to admit that I won't wait just because I'm in a hurry or I'm lazy.
Right.
But in an ideal situation, you would wait. You would let it mix up. You would mix up really good by hand. You let the aerators, the air stones do their thing, your pumps do their thing, whatever you can. But you would want to let it mix up and settle into itself before you take the measurements. Like when I'm pouring in the nutrients over there, it still has to, dissipate, diffuse into the whole amount of water. I'm always anxious to just grab it right away, but I'm like, God, I know that stuff hasn't gone through yet, and I need it to, you want it to make sure you get the accurate measurements.
Right.
In a pinch, if I'm outside or whatever, I'll just shake it up as good as possible. Another good rule of thumb is you want to add your micronutrients first, and then your grow nutrients, and then your bloom nutrients.
Okay.
The micronutrients part, I think that's just because there's so many different ones and they're in so small amounts, so you want to make sure that those are absolutely dissolved and available. But whereas, you know, when you're adding your grow and your bloom, those are like the macronutrients per se that you're providing in a lot higher quantities, and so even if some of it was to be dissolved or not in the solution, you would still have enough, or get a lot more than you would. You know, it's more tolerant of discrepancies.
So how long do you wait after you add pH up or down to like check the pH again?
Check the pH again. I would say like a half an hour, but like I said, you know, if you've mixed everything up like really good,
Then you're okay.
Then the less time is
I
acceptable.
actually use the drywall mud mixer with the drill and
Mhm.
mix the shit out of it. It's really
I've
good.
thought about that. I
It
have
works
one.
really good, yeah.
That's a really good idea.
It's like instant, you don't have to worry
So
about
that would definitely help. You know, things like that. Another thing that they do, like in an agricultural setting, or even when they're actually making these liquid fertilizers in the factories, is they use warmer water to get that stuff dissolved. And that's going back a little bit, talking a little bit about the difference between powders and liquids. You know, you'll find a lot of water-soluble powdered nutrients. Those are less soluble. Even though they say they're soluble, they're less soluble than water, than the liquid-based nutrients. So you gotta pay extra careful attention to make sure that stuff is mixed in nicely. I used to use powdered pH down when I first started out, and that was something in particular that I really had to pay close attention to because it's so concentrated that if you have to make sure it's mixed up properly. You know, otherwise you're gonna have pockets of like, you know, undissolved bits of phosphoric acid that are like really strong. So you want to make sure it's all dialed in like that.
Had somebody come and give me the same story as far as like mixing and find something else to do for half an hour, and then come back and check it. Because
Yeah.
really, if we stand and look at it, it's too hard
Right.
not to just start checking it. And
Yeah.
just plan it out. You put your newts in, you go walk around, you do this or that, and you come back and you check it. But if you use the swimming pool industry as any comparison, they say 4 hours minimum
Really?
after you add your pH up or down before you recheck. Because it takes that long because it's not just a matter of it getting dispersed. He mentioned in his thing, is because these are salts, they have reactions with the other things in the water. So it takes a little while for that to all get even and get steady.
Very true.
At the same time, I don't know anybody that waits 4 hours to check it.
Yeah. Well, and
Or
like
with swimming pools full.
a lot of times you can do that like what I'll do, I'll test my water, you know, like my plain water for instance. But the next time I do it, I know what my water was from before. You know, it's like if I'm mixing the same nutrients, the same concentrate, the same level as I did last week, you know, ideally you would test it again just in case like something happened, you know, just you might have some kind of fluctuation in your water source, whatever, but you know what the results you got before. So, you know, as over time, you know, you can start doing things like marking your measuring cup where how much you filled up and get an idea of, I used 1 cap full of the pH down for my adjustment, and that eventually that brought it out to where I needed to be. And so you can start not cutting corners, but sort of, you know, streamlining your process and making things a little bit, you know, quicker to work with or easier to work with.
I've heard it referred to as the recipe. Once you get the recipe worked out, it's
Yeah.
adding it at the prescribed amounts carefully works.
Right. Like, so like with my friend with the ketchup bottles, like he knew because he's done it 100 times, you know, that like a quick 2-second squirt was like what he needed, you know. But he had his truncheon meter ready to go, you know, measuring it all out. So it's like you still have to you know, make sure that you're within the parameters that you're going for.
Cool.
Right on.
Thank you.
You're welcome.
Thank you.
Thanks, guys.
Yay.